Hello everybody, welcome to another stream. How are we all doing? So last stream we were working on the gizmos and we got them working in terms of the rendering. This is the translation one. So if you hover over them, they sort of grow and shrink type of thing. And then when you so that's the translation. This is the rotation one here. Does the same sort of thing. And then this is the scale one, so it's got boxes on the end. We could maybe make them a little bit different, or like more different than the translation one that's got cones, but yeah. So we haven't got any of the user, like, we haven't got any of the input handling code. So when we click down and do stuff, it doesn't respond. We've still got to write that code. And we started writing at the end of last stream. So we'll be finishing that off today, hopefully. But I wanted to actually get started on something else first. And that is to do with, like, this is for the editor. But we do not have an editor folder within our source code. And I've just been chucking it in main.c, and it's just been making it get a little bit, the code's just been it's in place and things like this. So I'm thinking, let's tackle it from the other direction first. Let's get an editor folder and editor source files. We can write an API on how we are going to actually be using it, and then implement it using that. And then that way things will just be, I think will make a little bit more sense. So I think we're going to have an editor folder. We'll probably have a, we'll probably have one file for each editor, like a material editor, model editor, and a level editor, something like this. There'll probably be a common editor one or whatever, where everything will what everything will use, or something like this. So I think we might have editor.h, where all the editors go in to a single header file, and then we'll have a different source files, I reckon. So if I just create this quick, we have an implementation file for all the common stuff, and then we'll probably have another one like editor underscore material. So that's the material editor. That'll be a C file, wouldn't it? Stuff like that. Maybe we'll have another one for like model. Like a model editor, and then another one for a level. Right, so they can all stay in their own files and stuff, perhaps. Maybe. And the API is all in one header file. So if we go to one of those files now, let's go to editor.h, chuck the, we might have one internal header as well. I think I may be avoiding those recently. Yeah, we might avoid it. So yeah, we'll do the pragma once, and we're gonna have the so I guess we'll have just this spec that we will use to initialize it. So we can always add some stuff. editor in it, something like such, like this, right? So I usually have these sort of like these sorts of things. So we might have other sections in this file. This is the public API. We'll see. But for now, let's leave it like that. So, we need to include the core header, obviously. Engine core.h. So we then need to probably in the internal, the editor internal, yeah. Oh, do I not? Oh, yeah, I was thinking about removing that. Right, but the internal is going to have a bunch of internal functions that we're going to call across. Yeah, so we're going to need an internal header. Alright. Editor internal. Right, this was a copy paste. Cool, so this one's going to include the public editor header. And then this is going to be where we define the editor global, which has all the editors in here, basically, I think. Those editors as a whole. Hey there, Clarissa. Hey, thank you. Yeah, not doing bad, thank you. I got tomorrow off work, gonna spend it with the boy. We are just gonna hang around. It's gonna be pretty cool, pretty nice. Yeah, just been busy. I got my gizmos rendered now. So we're just hooking up the editor side of things. If I press the H key. Yeah, so that's what they look like. You can sort of grab it by a plane or by the arrows and they sort of respond when you hover over them a bit. Which is quite nice. And then I got the rotation ones. These are ray marched toruses because it was easier to ray march them. And then these are, yeah, just, the scale gizmos. So yeah, we just need to hook up the input code. But, so we can obviously detect when we hovered over it. It's just the input handling of when you've hovered and clicked on it actually change the values. So yeah, we're just hooking up the editor stuff now. And yeah, then just gonna make an API for it and test it all out. Hey, Devastated. Yeah, I'm doing good, my friend. Just had a pretty chill day, just just getting some fixes in the code base and starting on a new task. Yeah, not been bad. Watched the VODs a bit, lovely stuff. Sweet. Very cool. How's your personal projects coming along? Have you got back to working on them now? Because I remember you said you're just taking a break. So this is the internal. So in the internal, we're also going to have probably the gizmo thing, right? So we might have like an editor gizmo. So the way I'm thinking about it, right, is you edit the or the graphics header, the gizmo it wants. My laptop in the way. And I got my tower of Coke cans in the way. Hope it doesn't. There we go. So we have this sort of graphics gizmo type. Well, that's going to be accessible from the editor as well. The editor can probably know about the graphics. Probably not a bad idea. All the graphics knows about the editor. And these should be editor things. Yeah, effectively, we just want this graphics gizmo in the editor. Hmm. Yeah, I think it's okay this way around. Well, they can know about each other, maybe. No, they can't. Which way around do we want it? Well, the editor might want to ask the graphics to do stuff. Maybe. Confusing. Realized I would need asset streaming, got into the file reading more deeply, and end up in a mess. Maybe I'll post about it on Discord sometime. Okay. Right. Interesting. Have you got like an asset pack, or are you sort of just reading it from the file system for now? Hmm. Well, this is only an internal thing here. Yeah, I think we will include graphics. Makes a lot of sense. Right, graphics. Huh? Yeah, graphics.h. Good. So here's what I expect to be able to do. In the like we could do like we could do like a immediate mode API where every frame we call a function, and that just means you want that gizmo to be updated when you stop calling it. Or sorry, you want that transform to be updated when you stop calling it is when you will not want it to update anymore. Hmm. So we need to tell the graphics to render this gizmo. And then, or maybe, you know what, maybe we don't even need an API for it. It's just in the editor global, so you just set it. And then whenever you call when editor update gets called or whatever, it can have the graphics payload and it can write the information into the graphics payload. Yeah, I think that will do it. So yeah, maybe that's right. So we'll just do like a void something like this. And then in include editor.h. So yeah, nothing really to initialize yet. Oh, internal header. There we go. Ooh. I'll not use directly. Yeah, so in update, I think maybe we'll take in like a graphics payload. And then we'll literally just be like, you know, graphics payload gizmo is equal to whatever editor gizmo is. Alright, I was doing some coding, so I'll be in the background. Awesome. What stuff you working on, Mr. Devastated? I read an acid pack with a single compression for textures. Oh yeah, I remember you working on something like that, yeah. Not audio yet, right, fair play. Yeah, I've never done audio programming. Something I will definitely be learning for this project. Gizmo. Yeah, something like that. So, we must maybe be able to do the handling code in here as well. So if we put this, I think actually I need to now go into the editor internal header and take that graphics. And we'll actually include graphics in the public header of this because we need the payload. Yeah. So now, see, it makes me wonder if I need to clean any more of this other stuff up. Because I moved this camera code out and it's kind of annoying it just being there in the main function. Maybe we should organize things a little bit better. Because with the camera, like, so for the game, we'll have a camera. It's top-down sort of game, so it's going to be, one type of camera. We might switch between different cameras in the game. It depends how the vision goes for the game, really, but I think it's going to stay the same. But in the editor, we're going to be editing models and things, so you kind of want like an orbit camera and stuff like that. So maybe we should move this into at least a function somewhere, which we're saying update camera or something like that. Because it's just kind of in the way. This is a free cam, I guess. Would you call it that? Game engine camera types. Right, it's not fixed. Probably like a tracking camera, third person. Whatever that means. I did a portfolio website for a client. Oh, cool. And no, I'm not using C. It's cool. Nice. Yeah, it would be quite chaotic doing it in C. So the camera has like a position in world thing, as a view from world angle that it keeps around. I guess you'll call it like a free cam. Is that what they call it? Gotta be careful what I type in now. Game engine free cam. Is that what they call it? Because they can fly around basically. I don't know. Or is it a fly cam? I don't know. I'm not really sure this terminology, but so where would this go inside our hierarchy? We could put them as part of the engine, right? Just have like a cameras thing, but it's kind of like going to be a very small file. and I kind of hate that stuff, doing that stuff. You know, we're going to be probably adding arrayverse plane function today. That will end up going probably in the in the core section, but cameras aren't really core. Core really seems like memory allocation and that, and maths. But this is maths, right? It's just maths. It'd be weird putting it in the core section, I think. What's in core shared again? Is that where some of the color stuff is? Yeah, I got the matrix. The matrix is in here. And I'll probably put some of the geometry stuff in here as well. Like a camera is basically just trying to say make a matrix, isn't it? If it's had a camera.h and camera.c, it's going to be so empty. I think it's going to be a horrible thing to do. Maybe let's just stick it in core for now. No, core sounds too... It's quite a difficult thing where to place it, so maybe I won't solve this problem today. Well, let's make it at least a structure at the top of the file, and we'll I guess we'll just call it a camera. For now, it's just gonna be a free cam, but I guess we'll extend it to support all the other types of ones. So position in world space, that was one of them. Then there was the rotations, wasn't it? The rotation angle thing. This thing. Alright, so what else is this doing? So it just needs to create the view from world matrix, doesn't it? So I guess we could say put in here matrix view from world. So we'll call it angle, and then we'll call this position in world. And then update is literally just gonna take in the camera and then update the view from world matrix. That's all we need basically, isn't it? And then the graphics camera. We should probably put like the field of view in there as well. And so I can do like the projection stuff too, maybe. Where is it? Do not have a... Yeah, I don't really have a projection matrix yet. We just do ray tracing in view space, and then we manually transform stuff from screen space or view space to screen space by doing stuff like this. So we don't really have a projection matrix. So let's put field of view in as well as another parameter. That'd be fun. Right, that's interesting. So this could kind of actually just be in so you kind of want this maybe available on the GPU itself, right? Because some of the stuff would be useful, but maybe the GPU has its own structures. Yes, for now, let's just keep it as what we need here. Okay, so this is the update function effectively. So let's take that around. And yeah, we'll just put that in there like that. Okay. Camera, position in world. See, there's an if trap mouse. Well, yeah, that will be saying don't update the camera, basically. This is the stuff that we would give to the render thread. So I guess we'll... Right, so there's also like speed of things. Very interesting, and I need a bit of DT to be passed around. Or passed in. DT I usually like to make global. They don't pass it around everywhere. We'll pass it in this instance. We don't have one set up yet. So yeah, speed is an interesting thing, right? And look speed. So I guess these can be parameters here, like move speed and look speed. We'll leave them alone for now. Whenever we do different camera types, we can sort this out. So this one gets replaced with camera angle. Very nice. So you create your rotation transform. If you press down these keys, you got some delta. Delta in world, and then you move the position in world. Then you produce your translation transform. And then you produce your view from world. Right, so this is where we do the... Cool. So now when we do that graphics render frame. Okay, so we deleted all the... Right, so if not trap mouse. Oh no, if trap mouse, because it's trapped within the view. We want to say camera update. That just makes it a little bit nicer. So we've got a thing called like a graphics camera here. I guess we can now replace that with the other camera, or this camera here. So we can instantiate it here if camera dot field of view equals 0. We can initialize all the parameters. So camera position in world, we wanted it to be 0, 0, -4. So just a bit back, you know. And then we wanted to also have field of view. Right now I've hard coded to like 120 for some reason. It was because I was testing out the extreme cases when I was doing the rendering, and I kind of just left it at it and didn't really change it. So yeah, we're gonna have a super wide field of view for a while until we get back to rendering code. So yeah, we'll just pass in the camera like that. I don't know if we'll have multiple cameras. I don't know. Pass in our hard-coded DT. We might have multiple cameras for the editor, I'm not sure. Then after this, we'll say camera.position in world space is camera view from world, and then the inverse of that, world from view. Camera dot something like that. Okay. Do you want to pass in a FOV as well? I've not got that yet. Camera.fov. Right, so nearly there. We'll just do a camera, an FOV in here, and then inside the graphics where we hardcode our FOV, we'll actually make that equal to payload camera FOV. Right, so that's a minor improvement. I'm glad we've done that because it keeps a lot of the code out, or it keeps this code outside of the main loop, and yeah, it was just getting a bit messy. So now we want to talk about the editor, the way it's got to make it's got to do the gizmo logic. So I think we're going to do right, you might need the view from world. So I think you need to process input, right? Wherever that is. Well, here's all the input events and stuff like this. But I think there should be a place. UI text update, right? And a bunch of weird stuff. Yeah, so I think what we should do at least is update the camera quite early on. Yeah, you update the camera quite early on. Or maybe, maybe it's got to happen at least before the editor. And then you update the editor afterwards. Editor update. This one was the graphics payload though, so I guess the editor gets updated last. Okay. Maybe this doesn't need, maybe you can ask for the gizmo. Maybe you get pointed back to the you want to get back the gizmo that got stored inside the editor. Store gizmo. So effectively the update's going to not have anything passed in, at least for now. And we want to be able to probably get So the gizmo is stored internally. We essentially want a way to access the gizmo. Just read it basically and store it in the payload. But maybe the editor doesn't have to know about the payload. It could just... Well, no, it has to know about it. Yes, the editor has the gizmo here, but it's internal. So we need a way to sort of read it out, basically. So I guess you could say gizmo read graphics gizmo, something like that. Right, I think that's quite ideal. So we'll implement these functions now. Well, let's use them. So editor update, we'll just update, and you should do that after the camera, because you might need to use the view from world inside the editor. Maybe this camera is going to have to be known outside. And then we can, for the payload, just simply do editor gizmo read address of graphics payload gizmo, and we'll just store it in there. So that function is terrible. Terrible name. It seems like you're maybe reading it from the payload or not. It's if you call it render, then it seems like you're actually doing the rendering. So update payload. Yeah, that'll do. Payload like this. Probably a bit more understandable. Okay, so effectively we now need to move some of this inside the editor. So we're going to have some kind of like input handling. It goes on. Yes, this one's just going to set it like that. Be quite simple. The editor update is going. This is where the input handling will go. So, right, we don't need that gizmo thing anymore. Right, so we need to instantiate our editor gizmo, G-editor gizmo, or from local, to identity. And then I guess we say, hey, if you've pressed the H key, change the gizmo to another one. This is just testing at the moment. Something like that. So G-editor gizmo. So it's just going to go to the next gizmo and rotate around to the next gizmo type. So translation, rotational scale. Cool, so I'm glad that's been taken out of this function. Then after we did the render frame, the GPU is going to render the gizmo and then read back the results from 2 frames ago and figure out which one was hovered over, because we'll hover over a pixel and while we're rendering it, we go, hey, are you the hovered pixel? Yes, I am. Right. Is this the closest hovered gizmo piece? Yes, which one is it? And it writes it out and we read it back from the GPU. So this is a sort of handling code after the fact. So I think what would be nice is if we just simply provide the gizmo hover state to the editor, and then next frame it would actually process, so have another frame of latency when it comes to the input handling stuff. But I think it makes more sense if we do it all in the same update function. Yeah, the update name is kind of terrible. We could break it down into smaller update things. But yeah, I think that's a wise place to start. So we'll have a way to sort of set gizmo hover. Kind of hate set functions though. So maybe we'll have update process graphics feedback. There we go. A little bit more like we're in control that way. And it's not just a set function. So ultimately this is probably just going to store something. There might be some more readback state we have. But yeah, so I think we're going to have a gizmo hover. So which gizmo is hovered over? So G-editor gizmo hover equal graphics feedback, which is the hovered gizmo piece. Yeah, that can end up being none. That's cool. Right, so now from within here, after we render a frame, we can say editor process graphics feedback, and there we go. The next frame inside the editor will end up basically just doing this input logic stuff. Super nice. So there we go. Got a lot of the crap out of the main function now, the main loop, and put it into some hopefully better structure. Hey Rust compiler, how you doing? Right, interesting. Like a deferred call. But yeah, I can't, to be honest, I can't really trust anything that Godot does design-wise. Because if you open up any parts of the engine, it's kind of horrible. Yeah, so now anything like this is actually just inside editor gizmo hover. There we go. Now gizmo press, what is this? Is this like a yes, if we've pressed it in type of thing. So that this actually now moves to, oh, this is cool. Right, so in the editor internal, this is some more Gizmo-y stuff. Typically, you probably put this in a structure of itself. You know, maybe you have an editor gizmo and it has a bunch of other things, like hover pressed. And perhaps that is a better call. So yeah, perhaps we should really just bust these out into different things. And then just have an editor gizmo. So we're not just saying gizmo underscore and, you know, something like that. A little bit nicer. So we have like a press state, what is pressed, what is hovered. And when we pressed it, what was the word from local back then? Yeah, that'd be super nice. So then inside the editor.c file, we've now got all of these lovely things here. So this would be gedit gizmo dot pressed, and just copy all of that like that. Okay. Gizmo hover gedit hover this properly. So it's gedit gizmo word from local. So we're going to change this implementation code in a bit, but let's just get it all compiling. We're going to need somehow to get access to the camera as well. So when we update the graphics payload, we now can copy the type field and then the word from local field, like so. So it's a little bit more involved there, but that's okay. Makes it structurally better inside the editor itself. And then you say edit gizmo hover, perfect. So what we're missing is gedit. Right. So we just need the camera now. I think I'll temporarily bring this function in, then we'll probably delete it. Camera probably needs to go in more of a common place now. Well, you know, I could just comment it out, to be honest. Don't think we need this. This is when you actually wait a minute. We've not actually got included in the editor anywhere, I think. Did we include the editor at the top? You know what I did? I probably pressed the button and it did this automatically. There's no way I will put that there. Right. And then include the C file. Right, fingers crossed this works. Oh, you need the camera. Wait, I did that. Compile without the camera. Oh yeah, we don't use the camera anymore. In here we ifed it out, didn't we? We need to find a way to get the camera in. I don't want to pass it into the function because then you'll keep passing it around. Maybe the editor has its own cameras. That it controls. And then when the editor's up, it's the one that sets the camera. Yeah, maybe that's an interesting idea. And that way, hey Lupo, how you doing? Good to see you. I played your I played your post rock stuff. It was good. Have you got any more? We played it all last stream, and you wasn't. Well, I don't think you was there either. But that's cool. Um, am I doing immediate style? I'm not sure if I'm doing immediate style. I was thinking doing an immediate mode API for it, but I don't need it. I think it's just a global, and we just poke the global variable, the global editor variables inside the editor code. That is. To be honest, the Go.source code isn't that terrible. It's somewhat readable compared to other C++ projects. However, the graphics implementation is subpar and full of bugs, but I agree. I haven't really looked into the graphics. What I've looked at is the the design of the scripting language, and then I've also looked at how everything is very OOP and um, yeah, very concerning. Like, you know, but you can get away with that these days for a game engine. Um, you know, but obviously when people try and do something a little bit crazy, they'll have to drop down into C++, um, or whatever it is. Yeah, I'm doing good. Progress is going well, man. We're just um, we got a very brief asset system in place. It literally just reads from an asset directory. We did it in one day. Just open up an asset with a path, close an asset, get the memory for an asset, and so that whenever we do any asset loading, we will do it through this. We can find all the places in the code base we need to improve the system further. We've wrapped up on the encoder stuff. We actually didn't finish it because we're getting it in the nitty gritties, but I've been working it on more of it off stream because it's just, completing the rest of it and just better off if it's just done off stream, I think. And we can actually move on to do some other tasks because we spent a good while on that one. So we're working on the editor gizmos because these are things that we're going to need for the editor. By November, I want to be working on the material editor. Just the basic implementation of the first one. We'll be able to change metalness, roughness, and albedo. After the gizmo, we're working on a color picker. And then we'll probably start on the material editor after that. So yeah, exciting stuff. We'll be able to actually make content soon. We'll gradually be able to make more and more content. First it'll be materials, then it'll be actually making a model, and then probably putting some levels together. Like very basic ones. Hey, Katsumoy. Is that a cold can of coffee? Yeah. Cold can of Pepsi Max. Do you have an option to set any letter in the text to any color easily, such as hello? No. My text rendering is like yeah, it doesn't have spans or anything like that. I just you render the whole piece of text at one particular style. I don't do an API like that. Some people, yeah, some engines have that, but I don't have that yet. To be honest, if I need that for the UI, I'll probably just make it like, say if it's like an RPG game, and you've got like text at the bottom, and they talk, they talk to you, and you want to have a different kind of font or a different color or a different, you want to have it in italics or bold based on some particular words. I would probably just basically manually do it for that type of thing, because I don't think there's going to be many places in the game where we will need that. So we'll just basically take the string of text, which would be probably localized as well, and then find some special characters which mean bold or whatever, and then just use the UI system and change out the style for that word. That's the probably way I'll just roll with it, because I don't really need it as a wide feature. So I think I just do UI text. Yeah, you put the rectangle down, the string, and then the style. So I'll probably just break the string up into little pieces, and depending on the case where I need to do that. CPP. Oh, let's do it. This one sounds a bit too chill. It's making me sleepy. Let's roll. All right. So camera. So the game can have a camera, the editor can have a camera. That'd be a good idea. That'd be a really nice idea. So I think what we can do is right, let's just get it running. Editor, G editor. Because I just forward declared it, I didn't actually declare it. Sorry, define it. Words. This is cool. Cool. Right, that's busted. We busted it. Ain't working. Why ain't it working? Oh, we're not calling editor in it, so we've not got we've not got an identity transform, have we? Right, editor spec. I'm not sure if we'll ever need one of these, but AO. Editor. Init. Right. Cool. So the gizmos should now. Nice. Yeah. So have a hover over them and it'll set the state properly. That's good. So, right, now we should move the camera into a place we could probably get the editor to make a camera. And then I guess the game will have its own default camera. Nah, we don't need that now. We're doing gizmos today. Yeah, but we need the camera. Yeah, no, we need the view from World Matrix or whatever, I think. Okay. So, where's this camera thing gonna go that we made? We had this problem before. I don't really want to make a camera file, because the camera file is just gonna have like 2 functions. And I don't like stuff like that. Where shall it go? Like, I guess you could have like a... I don't think we want like a whole camera system where you can have like a system which deals with the cameras and like somehow switches between them. I think that's... Well, okay, say if you have like... Um, do we need like a camera system basically? Um, yeah, we might do. Say if you like... Say if you switch between two cameras or you move one camera to another position, or you switch between two cameras, you want to like interpolate it, maybe? Interpolate its view from world, perhaps. Maybe. But we don't need that yet, obviously. So what we might do is screw it. Let's, because I cannot figure out best place to stick it. So I'm just going to make a camera folder in the engine. And we'll have two more files called camera.h and camera.c. I don't like it, but I can't think of anything better. It can't really go in core. Core's not for that. And if we stick in here, it's accessible at least, and we can make it systematic in the future. I'm not fussed about doing that now. All right. So we do a sort of like a camera.h, chuck it in there, go to the top, pragma once, yeah. I need a good old core, engine core.h. All right. And then we're going to simply take the update function and go to camera.c, throw it in there like that, and include the camera.h header file. Right, thankfully, OS is kind of accessible from here. Engine OS OS.h, okay. Looking good. So, this now means, so when we say camera in this sort of file, I guess we can call this like the game camera. And then the editor will have its own camera. So when the editor's up and updates, it will set the camera. Yeah, so you have your standard camera update, game camera update. But maybe we can have a graphics payload. Set camera or something. Because the payload can, or the graphics system can know about the payload set camera. I don't usually like having set functions, but it's doing more than just setting one variable, you know. So, oh, what am I doing? Void. So actually it's taking the camera from the camera system. Alright. That'll be pretty nice. And then this way the editor can use this function to overwrite the game one. Right, and it's only going to be used in the editors are not really fussed if they both run at the same time. Or one off the other, I mean. And waste cycles. I didn't pass in the payload, did I? Whoops. Graphics payload, and then game camera. Right, so definitely the payload. This is a good album. I need to start jotting these down. Is it Distant Dream? Before. Hey, Cranston, good to see you. Are you planning on doing environment maps? Multiple simple cameras can come from there. I've already got an environment map. But I don't know what you mean by the camera can come from there. I've never heard about that. Sounds different. I need plan on it. I plan on having an entirely separate repo for camera functionality. Right. Git clone. Git clone that. For personal projects, I like picking a design direction and going to the extreme and see how it plans out. Plan is to be able to be okay, I need a camera in this prototype, chuck in the right euro. That's cool. Yeah, I think I'm at a place in my programming career where I quite like the code I write now. Like, so as much as I would like to make all these little reusable libraries and things, I think what's interesting about this kind of project is that whenever I need to do a new project, I could literally just copy and paste this one and just edit it to what that project needs. Yeah. And I'm only really gonna be making games, not gonna be making applications. So, but I see what you're saying though. Having like a way just to quickly drag it in makes sense. But yeah, camera system could just be a header file if you wanted. Well, you gotta have like matrices and stuff, but yeah. I mean, like key maps for the code. Yeah. But I wonder how the key map can be associated to a camera. A camera's a bunch of settings, right? Oh, would you say that the cube map is a parameter inside the camera? Is that what you're saying? I've never. Oh, I see what you're saying. Maybe. Yeah, you have like the environment map selected in there, right? Maybe. Yeah, it's part of like the scene, isn't it? Yeah, I don't think we're that far yet, but yeah, that's a good point to think about in the future. Oh, what am I doing? So payload camera, field of view camera. Hey, why don't you have the camera? Right, I've not saved all the other files, isn't it? So it's not popping up. Cool. Position world space. Nice. So I got the super lovely camera set. We use it here for the game camera, but we put it before the editor update. The editor update is also going to do it to its own camera. Editor.camera. So when we instantiate, the editor, G-editor, the global editor. Position in world, FOV. Then we've just got to set up the so the internal header needs access to the camera engine, camera. All right. Yeah, maybe if we're gonna put like the environment map in there, maybe it needs to come out of the engine. I'm not sure. See how it goes. Why is there discrepancy in the naming for position in world space and in world? Because yeah, because there is. Yeah, in world probably reads nicer. World space is just quicker to type. Typically in shaders I use what? Yeah. Smart pointers. Oh yeah, you got another playlist. This is a great one of my faves. Okay, I'll put that on the get it ready. Nice. Thank you. Literally unplayable. Okay. It is unplayable right now. There is no game to play. Cool. So we instantiate the camera. And we can then also update it into the payload. Oh yeah. So, should we have a bit of a funky thing that goes on? Why don't we say geoda dot camera dot FOV. Well, should we do this? Yes, I think it won't break anything. Equals sign. Some value. Crap, I don't have it. Why? We need to make some like globally accessible things. Like, problem is like threads in the future though. Static float time. Zero to sorry, minus 1 to 1. Make it 0 to 1. Then make it make it minus 2.5. Yeah, that make it 0.7. Wait, 0.5 to 1. Perfect. So then we multiply by 120, whatever the FOV was. We should then see it all go a bit funky. Just to see the values in the editor camera, not the game camera. Alright, I need to go to my single compilation unit and just chuck in some stuff. Right, hopefully that works. Alright, clearly that ain't it. Oh, we're not calling camera update inside the editor. That would kind of be helpful. So we should probably update the camera first thing, basically. This fixes that problem. Editor geditor.camera. Delta time is a big thing, right? What I might do is have the delta time passed in, and then we store it globally inside the editor. And then that way, yeah, it's just easily accessible. It might be useful to store like some time since boot or whatever as well. Maybe. I don't know. Anyway, let's just use that. So DT. I didn't set it. Gedit. Right, let's try that. So hopefully it's not too fast. What? Did I put it in the spec or something? Right, conflicting. Right, DT's hard-coded right now because, yeah, I've not done the time stuff yet. So, there we go, field of view is changing. So this is the editor camera. Right. Boom. So it's overriding the game camera and sending that to the renderer. Sweet. So, yeah. Now we've finally got the architectural stuff out the way. I think we should probably get started on doing some Gizmo stuff. Yeah, it does kind of suck we don't have access to those draw 3D things inside the editor. Yeah, so so a really great API that we have on the GPU side of things in both shaders and on the CPU side is a draw 2D and draw 3D API. Maybe, right? It's worth just having that accessible on the game thread side. Because I see if we're doing this editor, the Gizmo was one of the things which we told the renderer to render for us, right? But what about if we want to just draw other things, like just like a box or something. Um, to represent that we've selected something. So I think maybe, maybe it's, or maybe we should save that for later. Yeah, perhaps we'll save that for later. Yeah. Let's just try and wrap up on the gizmo as much as we can. The reason why I wanted it is because I'm about to do some, like, write some code which would benefit from having the ability to quickly debug draw some stuff. So maybe we do work on it. So we've got this like draw 3D API, you see, and draw 2D API, so we can just draw these things very quickly, very easily. On the graphics side, you have to do it. So the graphics has an implementation. Maybe we should rename these to GFX, and then the other one is game. It all depends how we do threading later as well. So we could have one API for shader code, and then for the CPU side, you have to pass in an extra thing like where is it going to get stored. But that would just be weird. So if we make another one and we call it game draw 3D or game draw 2D, because if I just had it for the editor, it doesn't make too much sense. You might want it in the game as well to debug. Hmm. Right, I'm just going to take a quick 2-minute break, get another drink, and then I'll think about this. We may or may not do this now. Right, be right back. Alright, welcome back everyone. So yeah, I was thinking about this Draw 3D API. We're going to be doing like a ray versus plane. It'd be nice to debug draw the plane and well, maybe not the ray because it's a V-ray. But yeah, so it'd probably be nice to draw that at least from the editor code. So this is the API that we use in shaders and in the graphics system. So when you start the graphics system, it clears it. So I need a way to pass it in from the sort of game thread, if you will. So what I'm thinking about doing is, if you look at the shader code, this sort of like draw 3D. These done later on. Oh, they're done after the AMD's parallel sort code. Right, after utility functions and that, which I'm going to bring some of these out, like this redirection for UV type of one. Rightio, so what I'm thinking of doing is we actually instead right. Gotta be careful. So where could these go so they're accessible in just the game? And I guess the game, we need to have a common place so the game can just call. So I'm thinking of having this API for the shaders, prefix it with graphics or GFX for the graphics thread. And then for the game side, it can just use game underscore draw 3D. And that should work. We just got to find a place where to stick these enums and things. So it's got to be in a shared header. I could just stick them in a... So if I use the... I need to put in like a common head of these things. But it's not really part of the engine, is it? Because these are all implemented inside the graphics system at GFX. So do I need some kind of like game core type of thing? That just sounds very weird because the engine has a core already. Maybe the engine could define. Maybe I could put this sort of like draw, this debug draw as part of the engine. Because it makes sense, right? This game doesn't... So then the shader implementation also goes inside. Yeah, maybe that's what we should do. Maybe that is it. So this would be like draw. This basic drawing stuff. And maybe that is what we need. Shouldn't take too much to get this to go. So essentially we want a shared header file between CPU and GPU. We also need a GPU implementation file that we can just include. which implements all of the functions on GPU. Then we probably want an API which does it on CPU. Right, actually implements it on CPU. That would be interesting. Then do you want like just a draw.h? I don't know if we need those. Right, let's see how if we can implement this. So I think we'll probably make this API. They always need a draw.h. Yeah, this is gonna be great. So I think what we're gonna do is this goes in the new shared thing. This capacity is interesting. The max number of words to draw. So we can improve the implementation later on by doing like a tile binning thing. But it could, yeah, it's part of the engine then. That'd be cool. So draw shared. Oh yeah, this does like interesting. Oh no. We don't want to include that. Yeah, we're going to say if not HCC. The next thing to take is this API here. This one, it will be publicly exposed via that draw H file. And it's going to pragma once again. Did I? I think I pragma once did the other one. Then we include the draw shared. So that will be included in the GP file. This one will not. So in here, we're also going to have a structure, which is the draw 3D or the draw storage maybe. And in here we have basically all the words. So you have your global array of words. So there's the draw 3D words and 2D words. And that's all you need, I think. So these parameters here just basically get transformed into view space and then broken down into individual 32-bit words. And then the GPU consumes those. So the CPU side functions can actually take in a storage. Something like that as the first parameter, whereas the GPU ones do not. And then the storage can actually be globally accessible. We could probably do some shorthand functions. But maybe, we've just got to find a place where to stick the storage for the game at least. I don't know where I'm going to stick it. Yeah, this would be cool. So then inside draw CPU.c, we're actually going to go into graphics.c, and that implementation of draw 3D whatevers, which is all of this stuff here, is simply just going to get taken and then placed into its own file. So include draw.h. Okay, so this used to be some sort of global. No longer doing global. We now have these things called a thing called a storage. Yeah. Very nice. So yeah, that would be good. So we've got to, let's quickly just bust on here the draw storage. So we're just going to go ahead and find, whenever we do some kind of open bracket, I guess, I don't know, probably be quite a lot of those. Yeah, it's probably the best way to do it. Play the next album. Gotcha. That was a good album. You got a good taste. Right, draw 2D is the next one. So that was the draw 3D API and all of its glory. We have a GPU implementation of it as well, which works with buffers instead of CPU side pointers and things. So we'll be bringing that version over as well. That one we won't actually make physical changes to that one like we are with this one, because this one we need to have different storages for different threads, whereas GPU just has one. So yeah, here we go. So effectively what we're going to do is do some kind of like core stack count, I guess, on the storage draw 3D words, and what we want to do is make sure that the if capacity take the count, maybe do it the other way around, count plus the count, make sure it's less than or equal to the capacity, and then if it's not, we return null. So we'll be like I think I've got like a remaining, maybe. I got that. Cool. So we simply just right, then insert index. So in this case, we simply just do this. Call it pointer. Core stack push many. So address of storage, draw 3D words, how many words we're pushing on, count many words. And then we simply just write in the first word write in the first word the header. Well, the Z test into the header and the count into the header as well, and then we return the words. Then the functions that call this will be ORing the type into the header and then setting the rest of the words up. So now we need to then pass in storage every single time we call alloc words. Yeah, so what we need to do is do that. Storage. And voila. The hell's going on here? Oh, damn it, I hate these things, these blue ones. It always confuse me. Yeah, so the call site. Well, this is a bit of a problem. They don't know about the view matrix at this point. That is definitely a bugger. How would we get the view from world matrix? Re-architecting code. So we have this new thing called like a camera now, where you update and you get this view from world matrix. And you pass it to the renderer. Maybe, just maybe, you just simply set the matrix inside the storage, and then that's it. So you just have to make sure you keep it somewhat up to date, and that's probably okay. I think that's an okay solution for now. We can always change it in the future, so for that we need to do the thing we want to do is matrix. So that is simply a view from world matrix. So wherever we do this sort of ggfx dot, we now replace that with, oh boy, what happened there? We now replace that with storage view from world. Okay, so we've now done. What's happening with the torus? Is that something else calling the torus? For crying out loud. I hate those errors. Yeah, so the draw 2D needs to do basically what the draw 3D did. We're just gonna copy that like so, and then simply just, wait a minute. Oh, I didn't save it, right? That should work. Yeah. So draw 2D, right, plop that in there. So the draw 2D doesn't need a Z test. We do have a depth parameter, to be honest. Maybe there could be a bit of a Z test thing, but oh no, depth, yeah. It's always, Z testing is always on in a sense. So yeah, we use the draw 2D instead of draw 3D. And then we, it's as simple as that. So now the rest of these have to also use the pass the storage pointer into. So I've only really got a few of these guys. AABB, circle and vector basically. 2D at the moment, it's all I've needed so far. So I'd like to let's just sort that one. Okay, so I think this is this function all compiling now. So the next thing to do is to sort out the GPU side ones. I actually want to bring that into its own file now. So draw GPU. So dot header, I guess. So inside shaders, there is actually a whole draw 3D section. We can literally just take all this. Oh, my concern is, oh, right, okay. Oh, screw. Yeah, let's just take it all. Yeah, so this has a bunch of ray functions as well, but hopefully we are not using those in some other shader places. Well, we are including it, or we will be including it. Cool. Oh no, we need those ray functions. That's okay. Don't mind me. Right. So, got to include some of the HCC stuff. Some stuff like that. Right, this is using the Clang LSP, so it's not going to work. It's not going to bring up my compiler, is it? I think typically I haven't actually written shader code in Helix yet. So maybe it's best just to if-def it out based on something. Yeah, I'm not going to get any sensible errors here. Yeah, that should include the atomics, I think. Anyway, so we're not going to make any changes to these. These work perfectly. Ah, shoot. Okay, you know what? We're not going to do the GPU one today. It's probably too much work. But that's great. So let's actually delete that GPU file. Not a good idea. Instead, right, so we've done this shared one. Yeah, so inside shaders, we're going to want to make sure we include the shared include engine draw shared.h. So that's got like just some of these things here, enums and things. Radio. So one thing that we didn't do is implement the storage. Probably custom allocator. And then probably some kind of capacities for these guys. Let's just say capacity, words cap, something like this, yeah. Just do a quick and basic version of this stuff. So core stack init on the storage, draw 3D words, the allocator, and followed by the words capacity. Then we'll copy paste that and then obviously replace the 3D with the 2D. So now, inside the graphics thread place, right, there, we probably want just a global variable called like or ggfx dot draw, and we'll just call it that. And that way it should be quite easy just to put it in all the yeah, so we don't have those draw 3D things anymore. Oh, we do, crap. I'll delete this. I just copied it. Alright, so we can delete all this from here, because we've already copied it over. Very nice. So now we have to figure out right, so this words capacity thing was useful here. I don't know if we could grep for it quick. Draw 3D. Because on GPU we don't have this change size at all, do we? Right, the globals still exist. Oh, that shared header file still has it. No, it doesn't. I saved it, that's why. Okay, so we should probably have these defined at the top. This would just be known as like graphics. And then this way we can avoid overflowing. Yeah. So I'll just define them up here somewhere. Draw 3D words cap. We did like 64K. Ought to be good enough. I think that was right. Yeah. So what we need to do is have a storage on the game side and a storage on the graphics side, and then the one from the game side is passed in via the graphics payload, and then we put that one on first to the GPU buffer, and then we put on the graphics one at the end of before it submits it to the GPU. So we just got to be careful when we do this. Yeah, so this sort of words count thing, these things would be the things that we do to append it. So we probably want to have a nice function. We'll just call it void graphics draw storage draw storage upload. When you pass in your draw storage, and essentially it will just where have we done that? So none of this, yeah. Can remember where that was, quick. Right, just before globals. Okay. So essentially we'll get a place to upload. We want to say write. How much can we actually write? So have like a words count equal So we'll do like a remaining count. It's equal to draw. Oh, somebody did not spell storage. Storage. So yeah, we're going to do a bit of draw storage. Right. Pretty words, capacity, take, draw storage. So that's how many remaining. So then we say the words count is equal to the minimum between. Wait, sorry. I got that completely wrong. Graphics, draw 3D, words capacity, take away the number of words we've already put on there. Mix with remaining count. Take away the ones we've already put on there, so that's ggfx dot words count, yes. And then if words count, we have words to do, we then use the upload API. See, my concern is those we're capping it. That's a big problem because you'll have stuff which half renders. Yeah, it's actually quite problematic. Perhaps instead we should say only do it if you actually have room. If not, just don't render anything. Because I think it could be, well, if you read out of bounds, just a little bit out of bounds, I think it's fine because you get 0 data. So it might be okay, actually. Should be okay. Fingers crossed. Yeah, so upload words count worth. Don't know why this is complaining. No, it's because of this. From the draw storage data. Then words count. Right, so what we're going to do is copy paste this and replace the 3D with the 2D. And then, right, now we just got to call this based on those draw storages. So we've got to put the storage into place. So effectively, in the graphics global, I'm going to put a storage in here. Draw storage, we'll just call it draw. When we instantiate the graphics system, we can simply draw storage init. The allocator is an allocator somewhere. Static allocator. And then let's just put in a. Let's just use this one. I don't know. Let's change it later. So then throughout the so we've got to actually do the upload function. So by we're gfx globals was. We're now just going to call that graphics draw storage upload, and then she's passed in gfx.draw. So now all we have to do is patch the code where we have used these things. So draw 3D OBB is just going to then say G, or address of G. Or I could just say you know, it's not as shorthand. Maybe we can make some shorthand functions which do it automatically. It might be nicer. Maybe it's worth it. So internal.h. So I think we can simply just oh, something like this. Maybe, just maybe we could deal with multi-cursor. So we should be able to simply just or with a a bit of a paste. Right, I'm clearly not going to get all those things in, but we can work our way there by simply doing that. So now I guess we can just go over all those and well, we can try and do as many as possible. Oh, that one messed up. Back on that one. Nice. Right, let's start a line. And we'll just go through them like this. So I think that's most of them. Yeah, so now we've got to just manually do it, not too bad. Cool, the final one is z-test. Right, so now we've got these shorthand versions. Crap, I did do storage for some reason. That was incredibly dumb of me. What I'm going to say is G graphics. I guess I can now call it draw storage. And I meant to take the address. And then that will mean nice. Right. So now we can nearly test this. Storage. Beautiful. So now any one of those sort of draw 3D whatever functions that we end up calling, we've just got to be a bit, we literally just got to prefix them with graphics like that, and then they're using the one for the graphics system. And then we can build another shorthand one for the so this is for the gizmos. Technically, the gizmos could have been with this could have maybe been drawn from the editor, but we specifically put some. We have a special way of doing the hovering, telling the renderer where the which draw words are for which gizmo piece, so it can do the hover checking code while it renders. Yeah, so right, I think that's all the change we need. Did I include it in the main compilation unit? There's a new. Now we're on fire today with all this architecture. We've added editor, camera, and draw. And then we want the C file, obviously. Wait, CPUC in it. Why do we need a CPUC? Why can't it just be C, eh? Nice. Right, set it for a spin and see what happens. Well, 11, what is going on here? I've included some of them. My preprocessor, what have you done? I've exceeded the maximum number of tokens. Can't be. No, my compiler, what are you doing? So what did we do? We included... But don't these things have like pragmas on them? Right, so we included like a draw header, which in turn included... Right, it's included core or whatever, so it's pre-processing that. Wait. Sorry, I'm in the wrong file. Right. Right, that's better. Some bug there. Oh well. Right, there's still some 2D vector stuff apparently that I missed. Crap, somebody did not undo the deletion. Let's try that again. Crap. Right. So this actually needs to be available in the graphics shared. At the top. Right, so in graphics shared, we've got these here now. So inside the shader code, we're going to do this draw 3D words cap. This is the GPU implementation, so it pushes onto a buffer instead. Yeah, this will do the safety check. go. Right. Right, so we used to forward declare it, so we simply just do this. All these just get solved. Right, so now the client compiler is complaining. Right. Hmm. I miss these Boolean things here. Whoops. Okay. And then I kept paying. Oh wow. 12 months, amazing. Thank you for your support, appreciate it. Amazing, thank you so much. Been that long, eh? Interesting. But yeah, how's things been? How's life going? Appreciate all your support, sir. How's the wife doing? I think that might be it then. Oh crap. It works again. Does it? Wait, we're not seeing the debug drawing at all, are we? There's usually white boxes around here. And this field of view thing is going crazy. Alright, let's turn off that field of view changer that we added in. Don't need that anymore. That's good. Oh, we didn't say the view from world thing, did we? Like a melon. Right, so every frame, at the start of the frame, render frame, what you need to do is set GFX draw storage view from world to whatever payload camera view from world is, whatever it's called. Yeah, look at that. So that should be the thing we're missing because the draw functions kind of use that. Come on. That's not it. Sad. We're not doing the we should put a breakpoint in the upload then and see what's going on. That's bizarre. Oh. Oh. Oh, what's going on? I think we're not upping the count. Doing good, same old thing. Life is good, hanging in there. Awesome. Alright, Draw 3D's back in action. What the crap is this? I did not clear. That was very dangerous. We need to clear every frame. It is clear. We're just accumulating storage, draw storage. We should have a function for that. Draw.h storage clear. Is this album done now? Oh, okay. Thought it changed to something else. What? Alright. So clear is just going to be like the first one, just replace with some clears. Oh, for crying out loud. Oh yeah, we didn't call it. Graphics C, plop down here. But yeah, how's the learning going of C? Have you got a little project you're doing? Get pain? Oh, because I saw you post something. You posted a problem you're solving. It looked like you're following like some tutorial thing or something. I don't know. Oh, for crying out loud, it's in the damn CPU file. I renamed it. I think I need to close my editor because I don't know. Well, you'll close the buffer, isn't it? Yeah. Right, there we go. It's not infinitely putting boxes in. Then I can go to the gizmo and the gizmo shows up again. The hovering's not working anymore though. Sad face. I broke the hovering. Oh, that's way off. It works, kinda. Only one of them it works on. Right, draw CPU. Let's do a buffer close on that one. Right, I'll do it. Now I can actually delete the file. Cool. So in the graphics, how do we bugger that up? On the words count. Right, they're all set to the same thing. This is why. So what it actually needs to use is, rather than draw 3D words count, it actually needs to use storage.draw.count. So we basically keep track of the start indices every time we do a draw. Something like this. Okay. That should work. So the hover code should now work. There we go. Right, that freeze camera isn't working because all the reasons again. Seems like there's some mouse motion being passed in when I change the cursor from being hidden and shown. Probably because I warped the pointer or something. I forgot how I did it. But yeah, that's cool. So that trap mouse type of thing, if the mouse is hidden or not. We should probably have a virtual mouse hide show toggle thing built into the OS layer. And that'll work better. But until then, I don't need that right now. Or do I? We're making the ref plane 50% transparent, maybe. Well, like these guys. I've got the ability to do a border as well, so I could border them. Yeah, let me have a gander. I don't really have a way to do it transparent, but what I can is our voice. So border thickness. The problem is though is you won't be able to get the hit because it'll go through it. That's the issue if you make it a border. Yeah, we don't really support transparency either. Well, yeah, I'm gonna leave it alone for now. But yeah, I'll think about that in the future though. You know, because they might get in the way. Just been dabbling in pointers and whatnot. I was trying to pass in, and yeah, I don't want to define the size. Cool. Yeah, double array. Trying to handle that. Fair play. That's cool. Yeah, arrays in C are a bit weird. They're honestly the weirdest thing about C. Okay, so maybe part of the OS there we need to say os dot or internal dot h. Maybe where's the virtual mouse? Right, virtual mouse. So by default it's shown. The mouse is visible. Is shown. Right. So by default that is true. So when you instantiate the backend, no, not backend, what am I talking about? When I instantiate the OS system, we can then set gos dot virtual mouse is shown equal to true. Now there is a virtual mouse hide and show. Oh, for crying out loud, it's already a flag. Past Henry was better than present Henry. Feels demoralizing. Right. Past Henry made a flag. So we probably want to I've already done it. But we should probably have a way to show hide toggle. So at a press of a button, we can do this toggle thing. And then I think what's happening is that it's actually like if hidden, show, if not, hide. So I think as well when we go into the main function, we can enable the this lovely thing. It's gonna like print out all the wait, it already does it. Okay, it already does it. Which we'll find the log. But basically now we can't view the log in here. So when we press the escape key, what seems to be happening is that the Um, it seems like there's new input that just arrives out of nowhere. So if I simply just press the escape key a few times and then close the program, we find the log file. Where did I stick in the end? Build logs, yeah. Alright. Because the build directory is probably ignored from the git thing, that's probably how it does it. It's git ignored so it doesn't. Right. Anyway, yeah, I want to open up OS input. So yeah, fine. Open build log. Yeah, so press the escape key and then the virtual mouse moved. Right. So it ended up causing that. Oh, there's a move event that happened, right? And then we released the escape key. Right. We've got a raw and a virtual one. So raw is the actual physical keyboard, so you have multi-keyboards, multi-mice. And the virtual one is obviously the all of them together, I guess. Yeah. Whatever the X11 one is. Something like that. So I think in the OS layer we can go into the Linux implementation, and where we end up doing the hiding and showing is something probably to do with the warp. So when we hide, oh, do we warp it to the center, isn't it? Why did it do that again? One I'm not calling toggle anymore. Let's get it fixed up. Right, so we'll just say there's trap mouse crap anymore. We'll just do the hide show toggle thing, yeah? Then this would be like if OS virtual mouse is visible, is not visible, then we want to don't update the camera. So in the editor, we want to do the same thing. Don't update the camera if the virtual mouse is visible. So if it's not visible, we'll update it. I don't know what's going on there. Keycode escape. Oh, I've got it in two places. That's the old graphics one. Yeah. Let's have a bit of fun. Let's make it only update if it's visible. I don't know why that ain't working. Yes, it's not changing mode. I remember we had that hide. At the start. I'm confused why it doesn't do it. Alright, so I think we could put a breakpoint in and just follow it. I'm so painfully dumb and we're going through it. Debugger's gonna help us find it quicker. Right, so press escape. Okay. So it hides it. No, it shows it, sorry. Because it's already hidden, isn't it? Yeah. Alright, we'll keep that one. Apparently it's shown it. Oh shit, it's calling the backend function. Damn it. It should be calling the, Well, okay. We'll just copy that like that. If not, there's extra if statementy things. Sure. So that was the issue. Oh. Alright, so that should be better now. So it's still doing that warp thing. Maybe we don't need to put the cursor in the center and it wouldn't be... There you go, you got the cursor moving around. Right, maybe let's not... Yeah, I think I need to sort out my... My hide code isn't really the best. Probably why. Right, I think that's fixable and at some other point. I don't know, maybe we can fix that now? Or we can finish up on the... We want to have that draw storage so when we do the editor Gizmo stuff, we can debug draw like a plane. Which would be kind of nice. So yeah, where will we stick that now? So the way that I see it is the editor gets updated on the same thread as the game simulation. So realistically, you just have some kind of place that defines this global thing which is shared across everything. Now I used to have this thing called like game. Oh, I'll still have it. And it was kind of... It's got like a shared allocator in there. And it's like thread local storage thing. I don't know if it's a good idea. Right, I've just got some... So maybe we'll just stick it in here. And then it's just G game. And then we'll do all the draw debug stuff. And then maybe... We'll just use that across the editor and the game. And pass that into the graphics. And then that way we can... When we do this Gizmo handling code, should be a lot of a lot easier to visualize what's going on and find the problem. So in here we'll do like a draw storage, something like this. Engine draw. Okay. And then we've also got to implement these functions. So in graphics C, there is those guys here. So we need to simply just implement these. In game.c, just chuck them in there. And do a nice replace for graphics with game. And that should be what... we then got to send it to the graphics thread. So in graphics H, there's a payload. And when I say graphics thread, I don't actually have threads yet, but I'm making sure that I don't have to do a mega refactor later. Right, so the other one is why did I need trap mouse again? Oh, I did something silly, didn't I? Okay. Right, so in the payload, we're going to want to pass in a draw storage, and this is just game side draw storage. So we'll probably pass a so you need to double buffer them. Oh, the payload can just have its own. So if it's not initialized, instantiate it, and there will be the double buffer in them anyway. That's cool. And we'll just copy it over. So that's nice. So all we need to do now you see, I wonder now, maybe, just maybe, we only need the one. In the graphics, you can just upload the whole buffer. In the graphics init, we don't really need to instantiate this anymore. And have a separate one. We could just keep using the one. Maybe we make it a pointer. Then when you render a frame, you can say ggfx draw storage equal the address payload draw storage. Then in all those functions where we had that sort of ggfx draw storage, oh yeah, you gotta set that view from world, don't it? Nah, it's already set. We don't need to do a clear here, but we'll need to do a clear on the game side of things. Hey Hotman, no, we're not using it SDL. I wrote my own X11 stuff, and I did the Win32 one as well. So yeah, it's all just custom. Because I've done STL in the past a few times, and I've tried to do the OS abstraction myself, and then this time I just sort of fully went into it. I even got the gamepads working as well. So it's quite nice. Thank you. Yeah, it was good. Good fun. There is the past streams when I implemented it all. It was kind of near the start, actually. It's on the VOD channel somewhere near the start of the. I think it was after we did the custom allocators, we went straight into the OS layer and did it all. And then we did the GPU the first thing, then it was collections, and then OS layer. Let's get back into the graphics. Cool. Right, so from the game side, we need to instantiate the ggame.drawStorage. We'll just use the static allocator. For that, let's say 65k, I don't know. 64k, I meant. Yeah, so now in the main function, when we make the payload that we send to the graphics thread, kinda. We want to save it's not draw storage clear. Don't want to clear that, probably not. So we want to say if graphics payload, probably not here, it's probably right before we call the render frame. Right, so if the draw storage draw words, it's not instantiated yet. You know, maybe this could just be a function. Draw storage copy. So you'll say payload, if payload draw storage dot data equals null, then we're going to instantiate the whole thing. So draw storage init. payload storage. The static allocator will do. We'll only do this once, or as many times as we have payloads. We only have one at the moment, and then we want to use the capacity of one of those things. Cool. Now we actually want to perform the copying. So we resize. I think we just do the resize and then, oh shoot. Core stack resize. Payload. Payload, draw storage, storage, yep. So replace the 3D with the 2D. Now we simply just do a copy. And then again, the 2D, 3D with 2D. How many elements? Good point. Storage elements were draw 3D counts worth. Cool. Then we need to also make sure we copy over the view from world matrix. It's just the way I've decided to do it. Is have an extra one in there. It's only for the editor really and debug drawing, so it's not a big deal. So now we've got this lovely function. We can simply call it from the main loop, and as part of when we're creating the payload, we can just go graphics, payload, and ggame.drawStorage. So the game thread is gonna have its own draw functions and draw storage. That then gets copied into the payload, then the payload gets given to the render thread. We don't have a thread at the moment, but it gets given to the render thread. Then the render thread will use that storage in the payload to do any debug drawing that it wants to do, and then it copies it to the GPU. And then the GPU can also add its own ones to that buffer. Awesome. So let's give it a test. Do you support several GPU? I've only ran this on my laptop, which is Intel, and my AMD machine. I've had people, I think, run it on other cards as well. But yeah, it's just Vulkan, right? So whatever Vulkan works on, it runs on that basically. There are obviously limitations. It doesn't run on every Vulkan device, but kind of the ones with Vulkan 1.3. So let's give this a test. Hopefully it doesn't blow up the computer. And hopefully... Right, it seems to still be running okay, and the gizmos are still... What the crap have I done? No! My gizmos! What have I done? For crying out loud. We didn't set the view from world. There's the problemo. So you have to update the camera as soon as possible. And as soon as you update the camera, you need to say G game. Right. This is not my best code. Wait, what am I talking about? G editor camera view from what? Okay, that was the problem. Right, so gizmos are there working again. Cool. Well, the hovering and that. Great. So now we should have our. Sweet. That's good. That's good. That's good. Now we should have our custom draw functions. When we update the. So what would be really nice to see is if we can, in the editor update, just draw some stuff and see what happens, right? Can I do a draw, a game, draw, 2D, vector, right, center of the screen or something, to perhaps the to the right of the screen, right? Very inventive, I know. With a depth of, I guess, 1,000, I don't know. Thickness of 4 pixels, and then a color of white. So this does it from the editor side of things now, which means, no, it doesn't. What am I missing? Why don't you want to wick? Well, that's a shame. Let's think about it. Let's try and do a 3D one. So if I do a 3D vector, let's position it where the camera starts in world space. Try and figure out what the rest of this is. Thickness, color Z test. Alright, let's try that out. Maybe draw 2D is just broken. Oh yeah, I think that was it. Oh shoot, what's going on here? There we go. Yeah, so draw 2D is broken. I remember that now. Wait, is it? Yeah, I think it's something to do with the depth buffer. I don't know. But anyway, this is great. This is success. This is being told to draw from the editor code. And then passed to the graphics, and then uploaded to the GPU, and then rendered. Yes, it's really incredible. So now it means whenever we do any Gizmo sort of input code, we can use the debug drawing API in the editor code now and test out or visually see our parameters and help us debug it rather than just seeing, you know, rather than just looking at numbers. Right, so there's a bit of a detour today. We didn't even get to this bit, but I'll go over the plan of what I want to do. So last stream we was trying to think of like, right, let's move the gizmo out. Hang on a minute. Translation.z equal -4. Right, speaker 1. There we go. So effectively the problem we had last time is that, so we know when we hover over it, the GPU tells us this. When we render a pixel, we just, check to see if we hit the gizmo piece that we're trying to draw. And then we send that back to the game, and then the game tells the editor about it. Then the editor, on the next frame, looks at that hover enum, and it's like, oh, we're hovering over the Z component. So then it goes, if I click it, right now I need to do stuff. So the logic that we're trying to figure out is like, well, if I click it and then move it, how do I know how much it's moved? So the thing I was trying to do last time is I translate this vector into screen space and then do something, and then keep the old location, and then where I drag the mouse, keep the old location around, and then keep where I clicked the mouse, something like this. So I have that in screen space. Then when I move it to a new mouse location, I can sort of get a difference between the two. And I have to do a bit of like, like a dot product of like, because the mouse could be over here. So I need to do like a dot product between this directional vector and see how much does this project down onto this vector. But yeah, I was in that screen space, which kind of is probably it works, but the better approach would be to use a plane. Because here's the thing. All of the gizmos basically just need to know a position of the mouse on a plane. And so we could basically get a lot of code sharing, or the code could be a lot more simple if we simply just start off by getting the position on. So we figure out like what plane do we need. This one we need the XZ plane. This needs the XZ plane. So does this one maybe, the XZ plane. Then, this one needs the XY plane. This one needs probably the XY plane, and then this one needs the YZ plane. And then from that, you can do a plane versus mouse, whichever plane you needed versus mouse, and then that'll give you the position on the plane. And then with that, we can switch again to know which gizmo we're on, and then simply do like a dot product or something if it's one of these axis ones. Then if it's the plane one, we simply just, that is our location, so we just do the difference. I think it's something like that. So we'll get a lot of code sharing if we do it that way. The tricky one would be yeah, I don't know how we're going to do this one. You'll probably do the plane thing again, right? So we'll use the same plane code. Plane versus, yeah, so we'll obviously be using like IQ. There we go, I remembered his name. Intersection. Yeah, so there'll be a plain one here. It's quite a simple one. I would not be able to write like that. I always forget what divide dot does. I need to learn this. But yeah, so it's basically an offset your array origin in whatever space. I think we'll probably be doing it from view space. Well, we're probably doing it from view space anyway. we'll move the mouse into as a view ray. So that'd be 0, 0. And then yeah, ray direction, we can calculate that. And then the position would be, must be normalized. Right, I see how this works. Ray origin is okay. Plane is at 0, 0 origin. So then you have your ray direction relative, so it's in plane space. And then this will be the normal as x, y, z. And then what's w? W is the offset along the normal. Okay. Good to know. I don't think we'll need that offset. Yeah, so we'll just use this. We'll put it into the core shared somewhere because we'll need it on GPU as well. But yeah, for this rotation one, I think we'll probably get the plane that we're on. So this for this one, for example, will be the x. Yeah, the x plane. Wait, is that the right way? Yeah, it is. Good. So that's the x plane. So I guess if we move the mouse, what would we do for this one? So you remember where the initial mouse was, and if you move it, you might be better off doing polar coordinates, isn't it? Yes, you translate the mouse position into polar coordinates on the plane, and then you will keep the. You don't care about the radius one. What you care about is the other two, whatever they're called, the other angle, like the x, y, sine, cosine guys. Yeah, polar coordinates will probably do it. This one might be a bit funky. So if you're doing it from an angle like this, it might be a bit weird. But I guess, yeah. So when it's like practically 2D on, quite a difficult problem to solve. But yeah, this way is quite easy to solve. So yeah, I think we'll do the polar coordinate thing. Yeah, and then scale is just basically the same as the other one. So it should be doable next stream. Now we've got all the nice tooling in, and have architected the we've made the editor folder today, and a draw folder for the draw 2D 3D stuff, and a camera folder for the camera function, which might be a system at some point. But yeah, it's been a good cleanup session and organization. You keep the same system as translation, but add an angle to it. Ooh, interesting. You did the plane. No, I don't know what you mean by an angle, to be honest. Yeah, I'm not sure. Yeah, I think it would just be exactly the same. It would just obviously write to the different values. That's about it. We'll still use a plane, a reverse plane. Right. Sorry, you're talking about the rotation. Right. Gotcha. So you can select the plane. Right. Yeah, so I think we're maybe talking about the same thing, because I was just talking about we make it use the polar coordinates. And that is basically... Oh, right, no, but you're saying don't use polar coordinates, you're saying use the angle. Interesting. Maybe. Let's have a think about it. Get something visual in our face. So what you're saying is, right, so you get the x-plane, so that's imagine there being a plane instead of a red ring, there'll be a red plane. So you'll get your point on the plane. So if you click it, your point on the plane. If I move it across the x-axis to the right, it will increase. Or if I move it back, it will decrease. If I move it up, it will increase. Yeah, see, I don't know, or down. That's the concerning thing, right? I guess you only care about on the x plane. So then on this z one, you only care about the value that you change on the z plane. Yeah, maybe that is the better way of doing it. Because actually moving it around in polar coordinates might be a bit... Like, we just did it around by dragging it to the right or dragging it to the left. That might do it. When starting to move an input value could also be possible. Maybe you take whatever the current right vector is. I don't know, to the camera, right? And no, that'd be a bit weird. Yeah, maybe you take the... If I just did that there, right? Yeah, because actually a plane's got two different directions. You know, it's got this way, that way, and also this way, that way, so that's 4 different directions. Isn't it, obviously? So I don't know. Yeah, maybe polar coordinates is the way. Yeah, I guess you could try and detect what way you mostly drag first. Some kind of like section where it figures out, hey, which one are you kind of going in. But then the micro movements might be a bit of a, yeah, I don't know. But yeah, interesting. I'll think about it. Maybe polar might be easiest to do first. But yeah, right. So I'll, yeah, so for those who support me, thank you so much. Appreciate you guys very much. I'll upload the code right after the stream to the GitLab tonight. Next stream is on Thursday. At 4 hours ago. Wait, sorry, 3 hours ago, but on Thursday, and then 4 hours ago, but on Sunday, is when we'll be streaming. So hopefully Thursday we get this thing all wrapped up, and then on Sunday we move to the color picker. Color picker, we're probably going to be doing an OKLCH color picker. It's kind of like a new thing. I don't know how much will be like this one, but it allows you to do like values outside of the... Effectively, the main benefit, right, is you can just change the hue and it keeps the brightness the same. Pretty incredible. You can just change the hue. Wait, this is chroma. Whoops. Yeah, you can just change the hue and it keeps the brightness exactly the same, the perception the same. Because, red, green, and blue have different brightnesses. So yeah, we're probably not going to do it like this. We'll find a better way to do it. But it allows you to represent stuff outside the sRGB color range. We're not going to support HDR picker, just an SDR picker, because we're going to be having a material editor in the editor. So that would be Sunday's stream, hopefully. Right. So who is available? But yeah, have a good Wednesday, guys. I'll see you all on Thursday. Hopefully, I CC. So let's raid. Hey, it's Jundy. All right. See you all in the future one. Bye bye.